To understand a formula, you need to understand how that formula was derived. We're going to derive the 6 inverse trig functions using our knowledge of inverses and implicit differentiation. So first off, finding the derivative of arcsine. So we know that the inverse of sine is arcsine. But we can also think of the inverse another way. If y equals sine x, then to make the inverse, x equals sine y. And you might wonder, why would we use x equals sine y rather than arcsine? Well, we don't know the derivative of arcsine yet. And we do know the derivative of x and sine and y. So we're going to use the equation x equals sine y and implicit differentiation to find dy dx. Right, so if we've got 2 functions here. If we're using implicit differentiation, we need to take the derivative of both sides. The derivative of x with respect to x is just 1. The derivative of the derivative of sine y with respect to x is going to be the derivative of the outside, the derivative of sine, so that would be cosine y, times the derivative of y with respect to x. So that's going to be 1 equals cosine y dy dx. Now, we're solving for dy dx, so we need to divide both sides by cosine y. So 1 over cosine y equals dy dx. Well, great, we've solved for dy dx, but look at our expression. We've got a y in there. We need our equations in terms of x's, not y's. What are we going to do with that y? Can we make a substitution for cosine y? Well, there's one equation I know, and whenever I'm in a jam, I reach for that equation, and that is Pythagorean theorem. Sine squared y plus cosine squared y equals 1. So then I could solve for cosine squared y, and then I could take a square root of both sides. So we'll subtract sine squared y from both sides. So we have sine squared y equals 1 minus, did I say sine? Cosine squared y equals 1 minus sine squared y. And then we'll take the square root of both sides. So the square root of cosine squared y equals the square root of 1 minus sine squared y. And we can simplify the square root of cosine squared y. That's just cosine y. So cosine y equals the square root of 1 minus sine squared y. So we could replace that cosine y with the square root of 1 minus sine squared y. And now you're probably thinking, that's even worse. Right? Now not only do you have a y, you've got a radical in there and you've got an expression. Oh, this is just not getting any better. Or is it? At the very beginning of the problem, I said that x equals sine y. So if x equals sine y, conversely, sine y must equal x. Any place that we see a sine y, we could replace it with an x. So now we have cosine y equals the square root. Now that's sine squared y, so we're going to have to make our x squared. So that means cosine y equals the square root of 1 minus x squared. And now we could replace this cosine y with the square root of 1 minus x squared. So now we have dy dx equals 1 divided by the square root of 1 minus x squared. And guess what this is? All right, so arcsine's the inverse of sine, and so is x equals sine y. By taking the derivative of x equals sine y, we have discovered the derivative of arcsine. So the derivative of arcsine, dy dx, is 1 divided by the square root of 1 minus x squared. And here we have it on the next page. Right? So the derivative of arcsine is 1 divided by the square root of 1 minus x squared. Right? So the beauty of this is, number one, you know where the formula came from. It's just not some random formula we made up. Right? We derived it. And secondly, if you ever forget the formula for the derivative of arcsine, You can derive it as well. Only took me 4.5 minutes. And that's with me talking. Let's do the same thing, but for arc cosine. So we know that arc cos is the derivative, is the inverse of cosine. Likewise, we could also switch the x and the y, and we would have the inverse of cosine. So if y equals cosine x, then to make the inverse, x equals cosine y. And we can use implicit differentiation to find dy dx. Right? So arc cos of x is the same thing as saying x equals cosine y. They're both inverses. All right, so now we can take the inverse of all of these terms. Right? The derivative of all of these terms. So we want to take the derivative of x with respect to x. Of course, that's 1. The derivative of cosine y is going to be the derivative of cosine blup times the derivative of y with respect to x. So that would be negative sine y times the derivative of y. And we know the derivative of y with respect to x is dy dx. We do that all the time, right? When we have y and we take the derivative, we got dy dx. All right, so we have 1 equals negative sine y dy dx. If we want to solve for dy dx, we just divide both sides by sine y. So we have 1, and I'm going to put the negative up here. So negative 1 divided by sine y equals dy dx. And again, we have a problem because we have y's, not x's, and we need this in terms of x. So we need to make a substitution for sine y. Well, like I said, I only know one equation that I can use to help me in every situation. Sine squared x plus cosine squared, sine squared y plus cosine squared y equals 1. And now we want to solve for sine. So we have sine squared y equals 1 minus cosine squared y. And since we want sine, not sine squared y, we'll take the square root of both sides. All right, so that gives us sine y equals the square root of 1 minus cosine squared y. And maybe you're thinking the same thing. That's even worse than sine y was. The square root of 1 minus cosine squared y. What are you thinking, Ms. Mishagna? Except, I know one thing. I know x equals cosine y. So if x equals cosine y, conversely, cosine y equals x. And wherever I see a cosine y, I can replace it with x. And if I have a cosine squared y, of course I replace it with x squared. So now we have sine y equals the square root of 1 minus x squared. And now all we have to do is replace the sine y with the square root of 1 minus x squared. So now dy dx is equal to negative 1 divided by square root of 1 minus x squared. And since we took the derivative of the inverse of cosine, our cos is also the inverse of cosine, we have now discovered the derivative for arc cos. Derivative for arc cos, dy dx, is equal to negative 1 divided by the square root of 1 minus x squared. Notice it's the exact same thing as sine, except the sine. They're very related, cosine and sine. So the derivative of arc cos of x is equal to negative 1 divided by the square root of 1 minus x squared. My lines are not very straight on the smartboard here, are they? 2 down in 9 minutes. And so if you ever forget them, you can derive these too. Let's find the derivative of arctan. So we know arctan is the inverse of tangent. But we could also just switch x and y, and we would have the inverse of tangent. So if y equals tangent x, then to make the inverse, x equals tangent y. And that's much better than using arctan, because right now we don't know the derivative of arctan, and I know the derivative of x, and I know the derivative of tangent. We all know the derivative of those things. Then we know the derivative of y. All right, so now let's take the derivative of x with respect to x. Of course, that's 1. The derivative of tangent y with respect to x, we're going to have the derivative of the outside, tangent blop, times the derivative of the inside, times the derivative of y. So that would be secant squared y, so that's the derivative of tangent, times the derivative of y. And we know the derivative of y is y squared, is dy dx. I'm looking at secant squared, and now I got a square in my head. The derivative of y is dy dx. So now we have 1 equals secant squared y dy dx. And if we want to solve for dy dx, we're going to divide both sides by secant squared y. So now we have 1 divided by secant squared y equals dy dx. And then again, you're thinking, uh-oh, we have a y. And we have a square. The square is okay, but the y is a problem. So we need to make a substitution for that secant squared y. But I only know one equation, so I'm going to have to use it. Just going to have to keep relying on my one equation. Sine squared x plus cosine squared x equals 1. But I don't have any secants in there. I know, however, that secant is the reciprocal of cosine. And if it's the reciprocal, if I have 1 over cosine, then I would have secant, right? Because they're reciprocals. So I better divide everything by cosine squared x. Right? Because since cosine and secant are reciprocals, secant is the same as 1 over cosine squared. Or in this case, secant squared y is, oops, we have the wrong variables in here. So used to x's. Here, I'll just erase it. Maybe I'll erase it. I'm trying to erase it. There we go. Sine squared y plus cosine squared y. Let me see how many times I'm going to write x instead of a y. Equals 1. And like I said, I only know one equation, and we want secant, and that's the reciprocal of cosine, so we just better divide everything by cosine. All right, so sine over cosine, right, that's going to be tangent squared y. And, well, anything divided by itself is 1. And 1 over cosine squared y, that is secant squared y. All right, so now we have another expression, right, for our secant squared y. Actually, let me just reverse the order here. So secant squared y equals tangent squared y plus 1. And actually, I'm going to reverse the order of everything. I'm just going to put the 1 first. Because it really doesn't matter the order that actually, no, I'll leave it the way it was. It's fine. It's fine. I just want to switch the order so that we have secant squared y first and foremost. And again, it's not looking any better. But I know something. I know that x equals tangent y. If x equals tangent y, then conversely, tangent y equals x. So I'm going to replace that tangent y with an x. So now I have secant squared y equals, and since that's tangent squared, it's going to be an x squared plus 1. And now I can replace the secant squared y with an x squared plus 1. So that means that dy dx equals 1 over x squared plus 1. And guess what we have just discovered? We have just discovered the derivative of arctangent using x equals tangent over y, x equals tangent y, because arctan is the inverse of tangent, and x equals tangent y is also the inverse of tangent. And there we go. And here we are. So the derivative of tangent x is 1 over 1 plus x squared. And so it doesn't matter the order that you add things. I was going to switch it so it matched. It doesn't matter whether I have 1 over x squared plus 1 or 1 over 1 plus x squared, right? They're exactly the same.